And to begin with, got another scatter plot for you to do. This one's not as long as some of the others. But if you would, go ahead and then make the scatter plot for that data. All right, hopefully your scatter plot looks something like what I have up here. Now, you didn't have to go by, I went by 2s on the bottom, 5s on the y-axis. But it should still have the same general look to it. And I feel like we're doing pretty well on our scatter plots. I think you're pretty comfortable with those. Well, we'll come back to the scatter plot here in a second, but some things to think about as we've been doing our linear models. Kind of 3 things here to kind of summarize those, and then we'll start looking at how do we get the equations. The first thing, remember, if we're going to use a linear model, what that means, first of all, anytime I make a model of something, it's not exactly the same as what we're looking at, but it's basically a replica of what we're looking at. What I mean by that is, like, if you make a model plane or a model train, well, it's not a real plane, it's not a real train, but it has a lot of the same characteristics. So when we make a linear model, we're going to come up with an equation that basically fits our data, but it's not like it goes through every single point of our data. So that's something to keep in mind, is that line we come up with, it's not always going to go through all the points. And there'll be some instances where we draw that line and it won't even go through any of the points. It may just kind of split them in half. So don't feel like you have to have a line that goes through all the points that our data has on the scatter plot. Well, technically, you could use different models. You could use different linear models for different situations. But the one we're going to stick with is the one we've been using, our y-hat. And that's going to be our linear regression. So just remember, whenever you see that y-hat, that tells me I'm dealing with a model equation and not an exact equation. So those are all just kind of ideas that are in general what we're talking about when we talk about a linear model. It's a way to try to fit our data to an equation that, again, is going to help us make predictions. Well, so far they've been giving us those equations. They've just said, okay, y-hat is equal to such and such. We've been plugging values in, making our predictions. What I want to look at today is, all right, well, how are they getting those equations? Where are those coming from? If you guys need to come back to this, I can come back to it, or it'll be on Learning later, so you can get some of those things there. But the equation we're going to use is what's referred to as the least squares regression line, or sometimes it's abbreviated LSRL, if you ever see that. We're talking about the least squares regression line. But essentially, it's just the line of best fit. And we talked about the other day that this was the form we were going to have it in. Y-hat was equal to A plus BX. And we also talked about, just like any other line, it's going to contain 2 things. It's going to have a slope, which in this equation, which part would be the slope, the A or the B? The B. And it's going to have a y-intercept, which in this equation is the A value. But again, it's really no different than mx plus b when we did y equals mx plus b, same idea. All right, well, how are we going to calculate it? How are we going to find that when it's not given to us? Well, there's really 5 pieces of data that we need. Here are the 5 pieces that we're going to need. We need the mean of x, or in other words, we need x bar. We need the standard deviation of x. And then we need the same 2 pieces of information for our y's. So we need the mean of y, or y bar. And we need the standard deviation of y. And then finally, we need the R value. Now, the good news is all 5 of those things the calculator can find for us. And in fact, we can find the first 4 in just one process. So to find these first 4 things, we can do that on the calculator by using these steps. By going to the Stat button, choosing Calculate, and then the third option is something we haven't done yet before. Now, I'm not going to make you enter in these values into your calculator. I've already got them in mine. But when I go to Stat and I go to Calculate, we've done one variable stats in the past. Remember, that's when we found the mean and standard deviation. But now we have 2 variables because we have x's and y's. So I'm actually going to choose the second one, the one that says 2 variable stats. So I'm going to do Stat. I'm going to go over to Calculate, but now I'm going to choose number 2, 2 variable stats. So for this problem, if I chose number 2, I got to make sure L1 and L2 are the 2 lists that I'm using. But whenever I hit Calculate, it's now going to give me all those numbers it gave me before, except now they're going to give me not just the x's, they're going to give me the y's as well. So here's all the information for the x's. And then if I scroll down, I get the information for the y's. Now, I don't need every single piece of information there, but some of the key pieces we said we need. We need x bar. So x bar was 14.5. We need the standard deviation of x. So that's going to be this value, which if I round it off, it's going to be 7.1. And then I needed the same 2 things for y. So I needed y bar, and I need the standard deviation of y. Again, I'm going to round it off, so it looks like this will end up being an 8. So I'm going to use those 4 values here in a second. But the good thing is, again, I can find all 4 of those in one step or one process by using that part on the calculator. Then the R value, we've been doing that for a while now also. So for the R value, we're going to do our same thing we have been doing with our linear regression. So I'm going to do my stat, calculate, and then linear regression over 4. And so my R value is 0.92 for this problem. Put that down. All right, so I got all the information I need now in order to actually find my least squares regression line. Now that I know that the R value is, if I round it up, 0.92. So again, all those things can be found on the calculator that I'm going to use. Now I've got to be able to use them. So let's start with slope. So we're going to try to figure out what our B value is. Well, in order to calculate our slope, we're going to take the R value times. Now, when we talk about slope, it's the change in what first over change in what? The change in X or Y? Y over X. So we're going to take this R value times the standard deviation of Y divided by the standard deviation of X. So for our problem here, we said the R value was 0.92. I'm going to multiply that by the standard deviation of Y, which in our problem was 9.58. And then I'm going to divide it by the standard deviation of X, which in our problem was 8.71. So I'm going to type that in and we'll see what our slope is. And we'll just round it to 2 decimal places. So 2 decimal places, our slope is this, 1.01. So we're halfway there to finding our equation because we know what our slope is. Find our y-intercept. Find the y-intercept, we're going to start with y bar. And then we're going to take away from that slope that we just found, the b value, times x bar. So again, I got to go back to where those values are. So y bar was 21.2. Minus, we decided slope was 1.01. And x bar was 14.5. And so now we type that in. .555. So we'll round it off to 6.56. So my equation now would be this. I'd say y hat equals the a value, 6.56, plus the b value, which was 1.01, x. And that would be our linear regression equation for this one. Now, here's some good news. When you guys have been finding the R value, Notice what was right here. Now they wrote it in a little different order. They said y equals ax plus b. We've been saying bx plus a, but it's the same idea. So the way they've written it, a was our slope. Notice what they said a was. 1.01, which is what we got. Notice what they're saying b is. 6.54, which we rounded ours up to 6.56, so it's close to the same thing. All right, so really the calculator will tell us that value as well whenever we found the R value. Now, if I give you like a bunch of data, I'm okay with you finding it on the calculator, and we'll practice that more on Thursday. But some of the problems that you'll see, they won't give you like a list of data. They'll only give you these values. So if they only give you these values, like they'll say the mean of x is this, the standard deviation of x is this, the mean of y is this, standard deviation of y is this, and so on. If they only give you these values, we don't have a choice. We've got to use these steps that we did here. But if they give you a whole bunch of numbers, we can type it in the calculator and just find the value. Okay. So on Thursday, we'll kind of distinguish between the two. But sometimes we have to use this, sometimes we can use it. So it's a little bit tedious as far as the steps are concerned, but the nice thing, all this can be given to us. All right, last thing associated with our regression line. We've got the equation now. We know how we can make predictions, but sometimes it's good if we actually sketched it on our graph as well. Well, there's two main points when I'm going to make my sketch of my line that I want to make sure I use. One of those points is the y-intercept. Well, for the equation we just came up with, which part of that would be the y-intercept? The 6.56 or the 1.01? 6.56. So one of the points that we're going to plot is the point 0, 6.56. And we'll go back to our graph here in a second and do this. So that's one point that I want to have graphed. The other point I want to have graphed is this point here, where I'm going to make x bar the x value. I'm going to make y bar the y value. So for our problem we just did, x bar was 14.5, y bar was 21.2. So I'm going to plot the point 14.5, 21.2. And then technically to make a line, all I need is 2 points. So I'm going to draw a line that goes through those 2 points then. So let's go back to your graph, the one you just made, your scatter plot. And we're doing a little bit of estimating because we have these decimals in here, but I'm going to start with the one that says 0, 6.56. So I'm going to go on the y-axis and get close to where 6.56 is, and I'm going to put a point there. And then the second value, or the second point I'm going to plot is this one, 14.5, 21.2. And again, we're estimating a little bit, but I'm going to go to where 14.5 is on the x-axis. And then we'll go up to where 21.2 is on the y-axis. And we'll make a point there. And so to make my best fit line, to draw it out, I'm now going to draw a line that goes through those two that extends on through the picture. So that would be a sketch of my best fit line for that equation that I came up with. And you'll notice it doesn't go through all the points, obviously. It kind of splits those points in half on there. But I would use that as my model equation or my best fit line. So like I said, on Thursday, we'll kind of practice putting into the calculator, looking at it, also being able to do it when you're given those values versus a whole bunch of data values. And then once we've got it, we're back to what we did before, plugging in X's, making predictions, looking at the residuals, all those things that we talked about before. We'll start doing it again. 2.6 is what we just finished. We're going to cover 2.7 out of this chapter, and that'll really be the last section of this chapter. Okay, so we're kind of getting toward the end of this chapter. This is another kind of long chapter. There is a section 2.8, but we're not going to cover that. And then here in a couple weeks, we'll do a kind of a chapter project like we did for chapter 1, associated with all these concepts. So that's kind of what's coming up ahead. There is an assignment that I'd like you to do for Thursday. This will not include this section. It's only going to include section 2.5. So these problems from section 2.5 I'd like you to do for Thursday. They're on pages 135, 137. But I'd like you to do 1 through 11, and then 18 and 19. Those will be due Thursday. Thursday, I'll hand back your quizzes that you took the other day. I don't think, I haven't entered those in, have I? Okay, I'll catch up on that. I'll probably have to do it on Thursday. But I got to enter those in, and then you'll get those back on Thursday. If you